Alright, so in this video we're going to take a look at generics. So to get started, we're going to go ahead and create a program or a project, and we're going to call this the generics demo. Okay, so I'm going to have my file genericsdemo.java. I'll give it a class header. So I have our public class generics demo. I'll then give it a main method. So I'll have a public static void main, my string array of arguments. And inside of here, what I want to go ahead and do for it now is just include a single line to declare and construct an object for the ArrayList class. And since I want to go ahead and work with the ArrayList class right now, I also need to make sure that I include an import statement right here. So I'm going to go ahead and import our ArrayList class from that util package. And then right here, we're going to go ahead and make our variable for it. So we'll have our ArrayList, we have those angular brackets, and then we specify the data type of the individual items for the array list inside of those angular brackets. Then we'll give it a name, say like string list, and then we'll go ahead and do our object construction. So we'll use our new keyword. We'll have the array list. We'll use the diamond operator to just infer the type, since we've already specified it for the reference variables declaration. Then we can just assume that it's going to be a string. The string will be the data type for the items of the object. Okay, so right now we've got our setup right here, and with the way that I've written this right now, because of the fact that I've specified the data type for the individual items, and I'm using the syntax where we have these angular brackets with the data type inside of them, this syntax lets us know that what we're working with right now is actually a generic. So in this particular case, we're using essentially what we could describe as like the generic version of the ArrayList class. And in this particular case, we're working with strings as the individual items that we want to put into our array list. Okay, so because of that, if I were to start doing something with this, I would need to make sure that I'm adding strings to this. So as one particular example, I'll go ahead and use my name, and I'll go ahead and just add that to this array list. So I'm going to say string list.add, and then my name, Brandon. And then from there, I can go ahead and print that out to the console. So we can go ahead and do string list.get, and we want to get the item that is at position 0 in this array list. So if I go ahead and compile and run this, then the expectation is that we're just going to create our array list, we'll add a single item to it, and then we'll print that item to the console. So we'll go ahead and do our compilation of genericsdemo.java. We'll then go ahead and run it, and we can see my name printing to the console. Okay. So this is working with an array list of strings. If I were to try to add another item to this, but I don't adhere to that data type that we specified, so if it's not a string, say I want to add a number like 5, but I don't specify it as a string, instead I specify it as an integer. Let's say I try to do this, and I come over here and try to compile this. Then the issue that we're going to run into, we're going to get this error where it says no suitable method found for add, and then the data type int, and then it specifies the line where we're running into this issue. And the reason that it's doing all of this is that what's going on here is the way that generics work, or the most important purpose that they're meant to serve, is that they allow us to handle type checking at compile time. So what that means is that by specifying that the data type should be string, every time I try to add a new item to this array list, or if I try to manipulate the items in some way, say maybe with a set to try to replace one of the items with something new, it's always going to do a type check, where it's going to make sure that the item that I'm trying to put into the array list, or whatever I'm trying to manipulate the item to become in the array list, is always going to be a string. So anytime I try to put something that's not a string, then because of this type checking, we're going to get an error at compile time. It will not compile successfully, and we won't be able to run the program. Okay. So that's the one of the most important purposes of this generic. The other thing that's pretty convenient is the fact that we can also specify different data types. So in addition to being able to specify string, we could also specify data type for any one of our other classes. If I were to invert this, so that now we're working with integers instead, then line 9 is going to be the line that gives me a problem, whereas line 10 is perfectly fine. So if I try this, go ahead and clear this, compile it, And now we see that we have no suitable method found for add string, where we're trying to add the string with my name in it. And that's because of the fact that we changed this data type to be integer. So now our type checking is looking for things that are integers. Anything that's not an integer throws an error. Okay. But there's also another way that we could write our array list. So what I have right now, where I've specified these angular brackets and the data type, this is essentially the generic version. We could also remove this. So if I remove it there, I'll remove it here as well. And we could just have essentially what you could refer to as a naked array. So basically an array list with no type checking. And so what's going to happen now is, now I can just go ahead and add items of any data type that I want. So neither one of these lines is going to give me an error because we're no longer doing any kind of type checking. So we'll go ahead and clear this. We'll compile it. And now we don't get an error, but instead we get this warning. So even though we're going to get a warning like this, where it's going to tell us that our Java file is using unchecked or unsafe operations, this is just something to let us know as programmers that our code is not necessarily as safe as it could be, but it can still compile just fine, and we can still run it. So I've compiled it, and I can still run it, still get the same output as before. But of course now it's giving us this warning because of the fact that we don't do any type checking. And because of the fact that we're not doing any type checking, this could actually run us into other errors later. So say for example, we've got this print statement where we're printing out item 0, this string with my name in it. Let's say I want to try to concatenate to that this other item from position 1, so the number 5. So go ahead and get the item at position 1 as well. I want to try to concatenate these two things together and print them both out. And so if this was using normal type checking, where we were checking to make sure that every one of the items in this was, say, a string, then the expectation here is that this would work just fine without us having to do any additional setting up or configuring of these items, because of the fact that Java kind of behind the scenes is already looking through everything for us. But because of the fact that we don't have type checking, we're not going to run into an error because we're trying to combine two items that are not compatible with each other. At the very least, as they are right now, we can't just concatenate them together and then print that out to the console. Instead, we get this error telling us that we have bad types for our binary operator plus sign. So the usual expectation when we use this plus operator is that we're either concatenating two strings together or we're adding two numbers together. In this particular case, we're not doing either of those two things because of the fact that this is now an object of the integer class, and we can't just convert that to a string so that we can concatenate them together. Instead, what we now have to do is introduce another method where we're going to use toString to basically take this number, this integer, and then convert that into a string so that now we can do this concatenation. So go ahead and clear this, compile it again. We still have our warning telling us that we're using unchecked or unsafe operations. Oops. We'll go ahead and run it, and now we can actually get the concatenation of my name and the number 5. Okay. But ideally, what we really want to try to do is avoid this issue, and instead, we want to be very careful about specifying the type when we first create our array list. And so then we can go ahead and adhere to type checking whenever we specify the different items, and then we don't have to introduce additional methods or maybe additional typecasts to get everything to work together in order to make sure that everything is compatible. Instead, now we can just make sure that all of the items are guaranteed to be compatible because of the fact that we're doing type checking at compile time. So of course now if I were to compile this, I don't have to specify that either one of those should be converted to a string. I compile it without any errors by just using a get to get the two items. And now if I were to run it, now I can get the same output without that extra baggage. Okay. So now the next thing I want to go ahead and do, now that we've seen a little bit about using a predefined generic, this array list with this type specification, I want to go ahead and make my own generic class. And then also, once I've created the class and done a little bit with it, I also want to go ahead and make a generic method inside of this generics demo. Okay. So to start off with, we're going to make a second program, so a second Java file inside of your project if you're working from an IDE. For this one, I'm going to call this container. So I'm going to go ahead and save this. This is going to be my container.java. And so we'll have our class header, public class container, and then our body. But there's something unique about the header that I want to go ahead and do here. So as we've seen before, when we're working with our array lists, we have the specification for the type with these angular brackets around it. I'm going to go ahead and do something similar right here. So I'm going to have those angular brackets, and inside of here, what I'm going to put is not necessarily a specific class or a specific class type like string or integer or maybe the double class. Instead, what I'm going to put here is a placeholder that could effectively represent any class. So basically, it's a generic class. And in this case, a pretty useful convention that you can follow is to just use the letter T, where the letter T basically represents type. So basically, this could mean any data type in Java. Okay. And then what we can go ahead and do is create a field that takes advantage of whatever name we gave it right here. So that placeholder right there, we can use that throughout the body of this class. So we're going to go ahead and create a private. In this case, it'll be a private T, and I'm just going to call it a fairly simple name, just value. Okay. We can then go ahead and start doing things with this value, like being able to set it or return or get it later. So we'll do a public void. We're going to do set value. Do our T. We can call it value inside of here as well. Again, make sure that this matches up with whatever name you gave it up here. And then right here, what we can do is we can use the this keyword to avoid shadowing, since we're going to use the same name for both the parameter and the field itself. So say this.value equals value. We'll then go ahead and create a getter. So we'll do public. In this case, the return type should match again with this. So it's going to be public T, get value. And we're going to return whatever the value is. And then finally, just so we can go ahead and see this later whenever I start using it, I just want to go ahead and also include a toString method. So we're going to do public string, toString. And for this one, there's not really anything particularly interesting as far as generics are concerned. It's just going to be a pretty standard toString method. So just say the value for this container is, and then our value. Okay. All right, so now that we've got that, coming over here, I'm going to go ahead and comment out this code related to the array list that we were using. And instead now we'll focus on some code for our newly created container class. So in order to use this, we're going to go ahead and specify that name, so container. So far not terribly different from when we specify that we want to use the array list class. We just specify that name, array list. Just like with the array list class or any other class that can make use out of generics, we then want to specify the data type with these angular brackets. So we can do the same thing right here. So I'll start off by making something of the string class. So now by doing this, what's going to happen is that this string that I specified right here, when we come over to our class definition, anywhere where you see the letter T, you can effectively replace that with the class type string. So now our container will be able to hold strings. This value right here is now going to be of type string. When we specify it as a parameter right here, this value is also going to be of type string, and the return type of this getValue method is going to also be string. Okay. Okay. The next thing we'll go ahead and do is give this a name, so we'll call it string box. And this is going to be equal to a new container. And just like with our array list, in this case as well, we can just use the diamond operator to just go ahead and infer what the data type is supposed to be based on the data type for our variable. Then go ahead and call our constructor. In this case, since I didn't make my own constructor in the container class, this is just going to end up calling the default constructor. Next thing we can go ahead and do is we can take that string box and we can add an item to it. And in this case, we're going to use the setValue method to do that. So that's going to set this field. And again, because it's of type string, that means that right here we need to go ahead and specify something as a string. So I'm just going to use my name. And then finally we can go ahead and print this out to the console. So do system.out.println, and because I'm using a toString, I'm just going to specify the variable for the object itself right here, and we'll just get this statement to print to the console. So in this case, it's going to print out the value for this container is, and then my name, Brandon, at the very end of it. Okay, so go ahead and save all that. Come over here, we'll clear our previous work, we'll compile this, and then we'll run it, and we can see now the value for this container is, and my name, Brandon. Okay, and the really convenient thing about this is that in addition to what I mentioned before about being able to specify our type checking, another thing that's really useful about generics is, as the name would imply, they allow you to introduce essentially a generic data type, meaning that it's a data type that could effectively be anything. As long as we're adhering to this particular syntax, then we can basically make it anything that we want it to be, while also being able to handle proper type checking to keep everything safe and secure. So in addition to my string container, I can also make an integer container. So we'll specify the integer class here. I'll call this my int box. Say this is equal to a new container. Again, we can use the diamond operator. It'll infer that it should be of type integer. We'll go ahead and save that. Say underneath my string box, I also go ahead and set the value for this int box. And for this one now, what it's going to be expecting is an integer instead of a string. So now I can just go ahead and put in the number 5. We'll use an example similar to what we had before. And then right here, I can go ahead and print this. So do system.out.println. And we'll say int box right here. Okay. So we'll go ahead and compile this. Make sure that's capitalized. Okay. And now we can get the value for this container is and the number 5. Okay. So this is one of the really convenient things about generics. Essentially two things that we've seen now is the strong type checking, as well as the ability to specify any one of the different classes that we have to work with. Okay. And additionally, with this custom container that we made, just like with our array list, we could also specify this without using the generic syntax. So maybe we just make a container for this one. Since we didn't specify a particular type, I'll just call it box. Say this is equal to a new container. We also won't have the diamond operator right here. And then maybe for this particular one, I'm going to say box.setValue. And I can give it, at this point now, because I didn't specify a data type for it, this can take items of any data type. So this one, in this context, you could say that it is truly generic. It can take everything. So maybe I give it another string with a different name. So I could save something like that. But of course now, if I do something like this, because I didn't specify the data type right here, go ahead and clear this. If I try to compile this, it's going to give me this warning again saying that I have unchecked or unsafe operations. And while a warning like this, it won't tell me what line is causing this warning to get thrown. I can tell you now it's because of the fact that we're trying to set the value for one of the fields, or for one of the, for the field in this case, without necessarily specifying when we first made the object what the data type for that field was supposed to be. And so because of that, I could actually just change it over and over again. So in addition to being able to set it to a string, maybe later I could change it and have it become an integer instead. Box.setValue. And then change it to that. And then if we compile it again, we just get the warning, but we don't get any error, even though we've effectively managed to change the data type that we are, of the value that we're assigning to our value field. We've managed to change that from a string to an integer. And in Java, you really shouldn't be able to get away with doing something like that. Under normal circumstances, Java is supposed to be a strongly typed language. So being able to do something like this completely goes against the underlying principles of how Java is supposed to function as a language. So you definitely want to avoid this, and you want to make sure that you always specify the data type for your generics. Okay. Alright, so this covers generic classes as well as these generic fields inside of our classes. In addition to that, I also want to take a look at generic methods, essentially being able to create a method that can interact with objects of generic classes. So to do that, we're going to go ahead and create a second method within our generics demo. So we're going to do a public static. We can then go ahead and specify that this is going to be a generic by using the angular brackets and then specifying the data type that is going to, or the placeholder for the data type that represents our generics. So again, we can use the same convention and just say the letter T. We then want to go ahead and specify our return type. So the fact that this is going to be generic, this typing, as well as a return type are two separate things. In addition to this, we're going to have our name, so we'll say is equal, and then we can go ahead and put in the parameters for this. So in this case, for this is equal, I want to be able to pass in two containers. So we'll have our container C1, and then our second container C2. And then what I want to go ahead and do is just have a single return statement where I just return the comparison between the values to see whether or not they're equal to each other. So we're going to do a return. So I'm going to do C1.getValue. So we'll just go ahead and get the value that is in C1. We'll then use the equals method to compare that against whatever value is in C2. So I'll say C2.getValue. Go ahead and save this. And then right here, what I want to go ahead and do is make sure that when I do this comparison, we want to make sure that this T that we specified here, as well as the fact that we have this T for each of our two containers, that should match up in some way, meaning that we want to make sure that we're comparing two things that are two containers whose item, that field, is the same data type. So the easiest way to do that, I'm going to go ahead and remove this line right here. And right here, I'm going to modify my box to be of type string. This little operator right here. And then right here, we're going to just go ahead and do our comparison. So we'll say is equal. We'll put in our string box and just our regular box. And then I also want to go ahead and print this out. So I'm going to put this into a print statement. Say system.out.println. So insert it right there. And so we want to print out either the value true or the value false, depending on whether or not these are equivalent to each other. In this particular case, we're going to be comparing the strings Brandon and David, so the expectation is that this will print out false. So go ahead and save that. We'll come over here, we'll compile it. So we compile it. Obviously, since I've now changed box to actually have a data type specified when I declare it and construct it, we're no longer going to get that warning about unchecked or unsafe operations. We'll then go ahead and run this. And so now we can get the two print statements from our toString methods, and we also get the value false from our isEqual method in the generics demo class. Okay. And then if I happen to change this one to maybe also make this my name, if I compile and run this again, now we can see it printing out true. Okay. All right, so at this point, this is going to wrap up everything related to generics, at least on a fundamental level. There's, in addition to this, plenty more that could also be said about generics, but we'll go ahead and stop here. I think this is a good amount to cover for the scope of this course. Going into the next couple of videos, we're also going to be taking a look at two more concepts related to more advanced topics for classes and objects. Those are going to include the enumerated data type and then also garbage collection.